Alright, Algebra 1, here we go. 7-3, moving on. Multiplying powers with the same base. Okay. Our essential question is, how do properties of exponents make problem solving easier? Okay, we'll look at some of the examples of that as we go. Since we're talking about multiplying powers, that property of same base, remember the numbers down here, this is the base, that's the exponent. Okay. As long as the base is the same, you just add the exponents when you multiply. Okay. So when you're multiplying, add the exponents. And of course your a is not going to be 0, otherwise you wouldn't have anything there. So an example, multiply 4 to the third times 4 to the fifth, common base, just add the exponents, it's 4 to the eighth. Because remember, if you look at this, if you think about it, 4 to the third power is this, and then you're going to multiply it by 4 to the fifth. One, two, three, 4, 5, 6, 7, 8. Okay, so that little rule up there holds. -2, I've got t for a common base. When I multiply, -2 plus 4 is 2, t squared. Common base is -5. I leave it in the parentheses because that's a big deal. If you're taking -5 squared or -5 squared in the parentheses, those are two different numbers. One's positive, one's negative. So it does matter. But I have a common base here, so -2 plus a -7 is -9. Okay? Simplify. Same kind of deal. We're simplifying here as we go. We're going to continue on it and just add to it a little bit. Kick it up. -4 plus 7 is 3, so n to the third. When you get constants out front, numbers out front, multiply them. Remember, order doesn't matter, so I can rewrite this as 4 times 9 times z to the fifth times z to the -12th. So we're going to multiply the numbers out front. 4 times 9 is 36. Common z's, 5 plus a -12 is -7. Remember, we don't like negative exponents, so we kick them down in the bottom, okay, and make it a positive exponent. Just since z is the only thing taken to the -7th power, that's the only thing that goes down in the denominator. 2 times 9 times 3, or here, let me kind of just get the a's together here first, that's what I did. 2a times 3a cubed, 2 times 3 is 6, and then 1, remember, we forget this all the time. When there's nothing showing, there's a 1 there, okay, but we don't always write it. So that's 1 plus 2, that's a to the third. Now we're going to multiply times our 9b to the fourth. I can multiply the numbers out front, but a and b, those aren't common bases. So I just got to keep them like that. Okay, I can't combine them, so I just show that we're still multiplying them. So 54a cubed b to the fourth. If you get something in scientific notation, remember, order of multiplication doesn't matter. This is all times itself. So 3 times 5 is 15. Tens are common bases. 5 plus a -12 is -7. Okay? Is that in scientific notation? No, because my decimal point's here, and I've got 2 digits to the left. So I kick it over 1, and then because I made the number smaller, I got to make that bigger. And remember, -6 is bigger than -7. Okay? So, multiplying powers, if the bases are the same, add the exponents. Okay? If you got numbers out front, multiply the numbers out front like you normally would. Common bases, add the exponents. Okay? We're going to look at that in class here tomorrow and some application of it. We'll get after it then. See you then. Bye.